Greetings everyone, this is Masum from Kent State University. I will walk you through my presentation on a wire-driven multifunctional manipulator for single incision laparoscopic surgery. I'll start with some details on what a single incision laparoscopic surgery is. It is a fairly new kind of minimally invasive surgical procedure in which the surgeon operates almost exclusively through a single entry point. This procedure offers a couple of major benefits over traditional surgery procedure. For example, this is a virtually scarless procedure with reduced pain and recovery time. It also lowers the risk of infection. Although this procedure has lots to offer, it suffers from some major limitations from technological standpoint. Developing proper tools for single incision laparoscopic surgeries and giving them multifunctionality is a major challenge. Without multitasking tool manipulators, surgeons need to change the tools manually, which increases the surgery time, risk of infection, and surgeon's fatigue. This motivated many research teams to develop multitasking tool manipulator. Our research team has designed and developed automatic tool manipulator suitable for single incision laparoscopic surgeries. The design novelty of this manipulator is that it's wire-driven, which eliminates the requirements of having any on-site DC motors. It can be manipulated remotely as it removes the requirements of an on-site motor. The chance of damaging motors or sensors for sterilization procedure has been removed and a safer tool changing robot has been developed. I will now briefly describe the design method of this multifunctional manipulator. Our 3D printed prototype has a cylindrical shape with 24 mm diameter and 44 mm in length. The key components of the structure are a tooltip, a top hat, a lead tube, and a tooltip container. The container can accommodate up to 3 tooltips. We have built 3 different tooltips with 3 different colors for demonstration purpose. Let's now see how this wear actuation works. We have 2 wear wound at the bottom shaft of a tooltip container. The lower wear goes clockwise and the upper wear goes counterclockwise. The container rotates counterclockwise when the upper wear is pulled, and the container rotates clockwise when the lower wear is pulled. The tool selection is accomplished through this rotation. The function of deploying and operating the surgical tooltip is realized by pulling another pair of wears fixed on a nut which can move up and down along a lead tube. The slot at the bottom of the selected tooltip is docked with the extended part of the nut. Thus moving the nut can realize the tooltip moving up and down. Once the tooltip's upper part reaches the top head, it is locked with the head by rotating tooltip container. Thus the up and down movement of the nut can be used to operate the selected tooltip. To switch current tooltip to a new selected one, the tooltip container is rotated to unlock the upper part of the tooltip, and then the nut retracts the tooltip. A new tooltip is selected and deployed in the same way as the old one. There are 5 important steps in this tool changing procedure, such as tool selection, tool advancement, tool locking, tool unlocking, and finally tool retraction. Now let's talk about results. We have used 2 DC motors to actuate the whole system, and we have used an Arduino Mega for the construction of the control system. And compared to previous research of our team that takes around 21.8 seconds to realize all the 5 steps mentioned above, this improved mechanism takes around 8 seconds to do the same task. And here you can see a video that shows the tool changing procedure. So in a nutshell, this new word-driven manipulator shows significant improvements in efficient automatic tool changing. This word-driven mechanism minimizes the potential damage from sterilization since the electronic actuation and sensing are located remotely. Alright, this wraps up my entire presentation. Thank you very much for watching. Have a good one.